In this video from the summer school exam questions, we're going to look at those about using logarithms. And there were 4 questions, 2, 13, 14 and 16. And we're going to take those in order. So these are questions where you need to use logs in order to solve them. So the first one we're going to take, we don't actually see logs mentioned in it, but when you've got x as a power, usually you take logs, and that's exactly what you do here. So the first thing I'm going to do with question A here is simply take natural logs of both sides. Now I could do this in any base. I could use logs to base 10 or base 2 or anything, but it's really easier just to do the natural log of both sides. So it must be true that the natural log of 3 to the x is equal to the natural log of 5. Okay, that's the first statement I'm going to make. And by applying the rules of logs, you know that you could take the power of the 3 and put it in front of the log. So that implies that x must be, x multiplied by the log of 3 is equal to the log of 5. So you just have to rearrange that now and divide log 5 by log 3. So x equals log 5 over log 3. Okay, and if you put that onto the calculator, you are required to give the answer to 3 significant figures where appropriate. So if you put that into the calculator, you will find that that will give you 1.46 to 3 significant figures. Okay, and that's the answer. And as I said, of course, you could have put that log in any base you liked. It wouldn't have made any difference. You would have always got the answer 1.46. Okay, so that's part A out the way. Part B is an equation to solve to find x, and x appears in 2 places. So the way I would write this out first of all is to recognize that 2 can be easily written as log to base 2 of 4. And that makes it a lot easier to work with, because once you've got every term as a log in the same base, it's very easy to deal with. So my first step is to write that down like this. Log to base 2 of x. And if you don't know these logarithm rules, you've really got to learn them, okay, because they are vital. So this is the same as log to base 2 of 4, simply because 2 squared is 4, you see. So having got that, I can now use one of the rules of logs here, and when I'm subtracting 2 logs in the same base, I can put it as a single log with a division. So the left-hand side of that equation can be written as log to base 2 of, and it's 2x plus 1 on the numerator, divided by x on the denominator. And that is equal to log to base 2 of 4. Okay, and because they now have log to base 2 in front of both sides, I can just effectively remove the log to base 2's. Okay, what I'm actually doing is I'm raising 2 to each side of the equation. So I've got 2 to the power of all of that is equal to 2 to the power of all of that, and therefore the log 2's and the 2's cancel to give me simply that 2x plus 1 over x, okay, is equal to 4. And that's effectively what's happened there. And then you just solve that linear equation and it's very easy to solve. You just multiply by x. 2x plus 1 equals 4x. Okay, so just do that under here. 2x plus 1 equals 4x. Take away from both sides 2x. 2x equals 1. X is therefore a half. Okay, and that is your solution to the equation for part B. Okay, so once you've removed the logs, it becomes a very simple process to follow. Okay, second question on logs was 13, and I've reproduced it here. So we will go through that in the same sort of way, step by step. So let's have a look. We have here, well, the first thing to do here is you should recognize these powers of 2. 32 is 2 to the 5 and 16 is 2 to the 4. So the first thing I'm going to do is recognize that and say that, well, actually, before I do this, I've got to do part A, haven't I? Let me do part A first, because that probably leads into part B. So let me just do part A first. And that's quite simple because, of course, y must be 1/8, because 2 to the power of -3 is 1/8. Okay, so y equals 1/8, and if you need to qualify it, since 2 to the power of -3 is equal to 1/8. Okay, and that's just using the rules of indices and the definition of what a log actually is. Okay, so I would just write something like that down to qualify the answer. So that was part A, and part B, as I was just discussing, was this. So 32 is 2 to the 5. So I'm going to write this like this: log to base 2, okay, of 2 to the 5 plus log to base 2 of 2 to the power 4, okay, and that is equal to, what I'm going to do now is I'm going to square, I'm going to take this log to base 2 of x and multiply it with this one to give me this, log to base 2 of x all squared. Now, of course, you have to be very careful here, because you see, when you're squaring that whole thing, you can't just bring the 2 in front. Okay, and people get confused with that particular rule. So just bear that in mind. Now, if we take this to the next stage, okay, we've got that this first part here, okay, is the same as 5 log 2, or 5 log to base 2 of 2. Okay, so this is where we can put the power in front, plus 4 log to base 2 of 2 equals log to base 2 of x all squared. Okay, well, that's obviously 9 log 2 to base 2. Now, of course, log to base 2 of 2 is 1, and log to base 2 of 2 is 1. So this left-hand side is just 9. Okay, so 9 is the square of log to base 2 of x. Okay, and that's sorry, that should be in there squared. And therefore, if you square root 9, you get that log to base 2 of x is equal to plus or minus 3. Okay, and that is where part A comes in, because of course we've already looked at that, and we know from that x can either be, well, let's just put it in two stages, so which implies that x equals 8 or x equals 1/8. Okay, because you see, if x is 3, 2 to the power 3 is 8, and if x is minus 3, 2 to the power minus 3 is 1/8, which we've already considered up here. Okay, so they are the two solutions that arise from that equation. There are other ways you can do this. I think that's the best approach for that particular question. Okay, now question 14. So in this question, we start by working out what x is in this part here. Well, we know that 8 to the power of 2 is 64. So therefore 8 must be the value of x. And we're only interested in the positive value. Okay, so I'm just going to write down for part A that, let's just choose a better colour. Okay, so for part A, I'm just going to say that x equals 8 since, just to give a reason, since 8 squared equals 64. Okay, so that's the first part done. Now, the second part requires us to use the rules of logarithms, several of them in fact, to eventually remove the log term altogether to solve this for x. So what we're going to do first is recognize that we can recreate this as follows. So I'm going to write log to base 2 of 11 minus 6x, okay, and I'm going to subtract this term from both sides, so I've got both log terms on the left, and I'm going to take away, now I'm going to write this as log to base 2 of x minus 1 all squared. In other words, I'm bringing this 2 up to here, okay, and then that equals 3. But I'm also going to make a note that 3 is the same as log to base 2 of 8, okay, because 2 cubed is 8. Now, that's going to be useful, as you'll see why in a moment, because I want to remove the logs entirely. So from that left-hand side, I can combine these two log terms into a single log and a division, because the division rule applies when you subtract the logs from each other. So log to base 2 of, now all of that in there would be 11 minus 6x over x minus 1 all squared, you see. And that expression in there comes about from using the division rule of logs. So that's that, and that is equal to log to the base 2 of 8. And because we have a log to base 2 of the left-hand side and the right-hand side, we can just take it away, and it gives us quite nicely that 11 minus 6x divided by x minus 1 all squared equals 8, or I can just put the x minus 1 squared, multiply both sides by that to put it like this, and then I can work on that quadratic, which will give me that 11 minus 6x, okay, equals 8x squared minus 16x plus 8. Okay, tidy all that up and I get the quadratic 8x squared minus 10x minus 3, okay, equals 0. And factorising that, always look for factorising opportunities, I get 4x plus 1 multiplied by 2x minus 3, okay, equaling 0. And that gives rise to two solutions, or apparently two solutions. We need to check them carefully. X equals minus a quarter, or x equals 3 over 2. Okay, 3 over 2. Now, before we conclude with those two solutions, we check them, because remember, a log cannot be taken of a negative number. So if we put x equals 1.5 into here, okay, 6 times 3 over 2 is 9, so 11 minus 9 is 2, that's fine. And if this is 1.5 here, 1.5 minus 1 is a half, that's also a positive number. So this solution here is fine, okay? If we take the other solution, negative a quarter, this will be positive. But if we put negative a quarter for x in here, it will give us negative 5/4 as the argument for log, and we can't have that. So this solution here is invalid. So we need to eliminate it, or show something to suggest that we've done that. I've done the tick and cross idea here, and therefore my conclusion is that x equals 3 over 2. Okay, so something to indicate that you've eliminated one of the solutions and are satisfied that there's only one that works. Okay, and finally we go to question 16, okay, from that particular collection of questions, and this was it. Okay, and here we have an expression in log to base 3, okay, and I can immediately write the first, the left-hand side of this as follows. So I'm just going to put part A here, okay, so I'm going to put the 2 up over here as a power. So I've got log to base 3, so log to base 3 of x minus 5 squared, like that, minus log to base 3 of 2x minus 13, and that equals 1, which of course is log to base 3 of 3. And that's using the idea that if we have all the terms in the same based log, we can remove it at some point. And we're going to do that very soon. But beforehand, we've got one more thing to do, and that is to recognize this as a division. So it's log to base 3 of x minus 5 all squared, okay, over 2x minus 13. Okay, so I'm just going to put that in its own large bracket, which is necessary, okay, to avoid any confusion. So that expression there, if you took the log of that to base 3, it would equal the log to base 3 of 3, okay, which is of course 1. Take the logs out and you're simply left with that all of this equals, well, if we just take the logs out, we've got that x minus 5 all squared, okay, and I can then go straight on to putting the 2x minus 13, multiplying both sides by that, will give me 3 lots of 2x minus 13. Okay. Just be careful about missing out too many steps, because very often these questions will ask you to show that something is true, and you must therefore put as many steps in as necessary. But anyway, this gives me x squared minus 10x plus 25, and that gives me 6x minus 39. If I convert all that into a quadratic, it gives me x squared, okay, minus 16x plus 64 as required equals 0. So we knew what we were aiming for here, but that's it, okay? So that's the demonstrating or proving the first part. Now, it says hence or otherwise. Well, that normally means hence. In other words, use what you've just done to solve this equation. Well, quite simply, I should recognise that from this, that is a perfect square. So x minus 8 times itself equals 0. Okay, that's what this is here. And therefore, the only solution that is valid from that is that x equals 8. Okay, and it follows on nicely from what we've just done, so it's very clear where that's come from. Okay, and that completes those 4 questions on particularly using and testing the rules of logarithms. Okay.